In this lesson, we'll go over a couple of examples of solving quadratic and rational inequalities, so we'll look at one each. Here in example 1, I'd like to solve this inequality, that is, where is x squared minus 4x strictly greater than 21? To start with, I'm going to change this to the following. X squared minus 4x minus 21 is greater than 0. So with inequalities, comparing it to 0 as opposed to here 21 will be a little bit easier for us to solve. So step 1 is, don't figure out the greater than 0 part, but actually figure out, well, where's the thing actually equal to 0? So we're switching the question briefly to solving this. Because if we can figure out where this thing is equal to 0, we can then reason out where it is greater than 0. To solve this equation, I'm going to factor. And to do that, I have to have an x and an x. It's got to be a positive and a negative because the last number is negative. I need two numbers that multiply to negative 21 yet add to negative 4. And that would be 3 and 7. The product is negative 21 and the sum is negative 4. Okay, with these factors, we can set each one equal to 0. And if I subtract 3 from the first and add 7 to the second, we have two solutions. We have x is equal to negative 3, and also x is equal to positive 7. So that's where this equation equals 0. But where is it greater than 0? To answer this, I'm going to go to a number line. And on this number line, I'm going to label negative 3 and positive 7. So we'll say negative 3 is here, positive 7 is over here. And at these two locations, this is equal to 0. So the place where the original inequality is greater than 0 can occur in exactly 3 places. Here, here, and here. So what I'm going to do is choose a number from all 3 locations, plug them into this part of the inequality, and if it makes it true, then that will be part of my answer. So here's what I mean. Maybe I'll use the number here, negative 4. Does x equal to negative 4 make this thing a true statement? So let's plug it in and find out. So let's see. That's negative 4 squared minus 4 times negative 4 minus 21. Is that greater than 0? Okay, I just type that into a calculator and I get 11, which is definitely greater than 0. Therefore, since this number made this a true statement, this whole region works. Everything that's less than negative 3. So that's part of my answer. Let's check these other 2 regions just to see what happens. Okay, so now I think I'm going to try, how about 0? I'll check that. If I put x equals 0 into this inequality, will it make it true? So let's see, is 0 squared minus 4 times 0 minus 21 greater than 0? And the answer is no, because on the left you have negative 21, which is definitely not greater than 0. That leaves us with one last place to check. That's a number over here, and I guess I'll choose 8. Let's plug that in. So does x equal to 8 work? Is 8 squared minus 4 times 8 minus 21, is that greater than 0? If I type that into a calculator, I actually get 11 again, and that is true. Okay, so I want to include this region. I do not want to include this region, and then I do want to include this region. I'm going to express my answer as an interval. So here is the answer. It is everything from negative infinity up to and not including negative 3. It is also everything that is greater than 7, and I want to include both of those, so I'll use this union symbol. So it's this stuff and this stuff. And that is the answer to this inequality. In example 2, we're going to solve this rational inequality. Rational because we're dealing with a rational function. where is x plus 1 divided by x minus 3 less than or equal to 0? We can take a similar approach as in example 1, where can we first figure out where x plus 1 divided by x minus 3 is equal to 0? So it's nice that 0 is already on one side, so where does this thing equal 0? And there's exactly one number for which this happens. If the numerator is 0, that is, if x plus 1 is 0, that will make the whole fraction 0. And if you subtract 1 from both sides, you get that x is equal to -1. And there's an equal sign here as well, so that's actually part of our answer. Now, there's one extra thing that we have to check. Not where this thing is equal to 0, but also where is x plus 1 divided by x minus 3 undefined? So we have to add in this other part to the process. So where is this? Not equal to 0, but undefined. Is there a number that if you put it in place of x, it'll create a problem in this function? And that's where your denominator is equal to 0. So we actually have to check this too, not just where's the numerator 0, but where's the denominator equal to 0? And the place where that occurs is, if you add 3 to both sides, that is x is equal to 3. Now, this number is in our answer, but this one is not. 3 cannot be put into this function because it's not defined there. When you put 3 in place of x, you are dividing by 0. So we're just going to make note of that. We can't use this number. Let's put all of this on a number line. So here's my number line. The numbers that are important are, first, -1. So I'm going to label this spot -1. And since -1 is actually included in our answer, I'm just going to put this closed circle here to say, all right, that number I'm using. Now over here is 3, and we don't want that in our answer at all. So I'm going to put this open circle here to indicate that, right, no good. I don't want to use that number. Now to solve the inequality part of this problem, we will check a number in these 3 regions. The numbers that work, we will use those regions. The numbers that don't, we will exclude those regions. So I think I'm going to choose, I'll try -2. I think I'll use 0, and then maybe I'll try 4. And I'm checking these numbers to see which of these 3 regions I want to include in my answer. So let's start with x is equal to -2. Does that, if I plug it into here, make it a true statement? All right, so if I plug in -2, I get this. That was -3. Okay, is that less than or equal to 0? And that simplifies to 0.2. And that is definitely not less than or equal to 0. So, no, I don't want to use this region. That's no good. Okay, let's try x is equal to 0. Does that work? So is 0 plus 1 over 0 minus 3, is that less than or equal to 0? And that's -1/3. And that's definitely true. -1/3 is definitely less than, well, it's less than 0, but it's less than or equal to 0. So yeah, we'll include that. And then the last one is, I want to check x is equal to 4. And let's see, so that is 4 plus 1 over 4 minus 3. Is that less than or equal to 0? I mean, I don't think so. That's 5. So 5 is definitely not less than or equal to 0. So no, I don't want that. And what this means is, in terms of the answer to this inequality, I want the stuff that's between -1 and 3. I want to include -1, and I do not want to include +3. So my answer looks like this. Close bracket, -1, comma, 3, open parenthesis, and this is my answer.